We're looking at a probability distribution table for the data that came from a survey where moms were asked, how many times do you wake after midnight due to your newborn baby crying? We see the variable values range from 0, 1, 2, all the way up to 5. So at the very least, the mom does not wake up at all. That would be x equals 0. At the most, we have some moms waking up 5 times after midnight each night because of their baby crying. We also have the corresponding probabilities. So what's the probability that a mom in this study wakes up twice after midnight due to the baby's crying? That probability is 23 out of 50. If we want to calculate the mean or the long-term average, or we can also call this the expected value of this probability distribution, we can do it by starting off with adding a new column into our table. This column will represent each variable value multiplied to the corresponding probability. So we'll multiply each value to the corresponding probability and record that in this new column. Next, we'll add all of those products together, and the sum of those products is the mean, the expected value, the long-term average. So over the long term, we expect mom to wake 2.1 times a night on average. Now 2.1 is not a discrete number, and it feels weird to use 2.1 to represent the average value of our possible variable values. It's not possible for a mom to wake up 2.1 times a night, but this is an average. So over the long term, this is the average, more than 2, but not quite 3 times a night. Now let's calculate the standard deviation. In order to do this, we'll add our first extra column to find the deviations from each of the variables and the mean. We calculated that the mean was 2.1. So we're taking each variable value and subtracting 2.1 from it to find the deviations. Now, some of our deviations are negative and some of them are positive. The variable values that are smaller than the mean result in a negative deviation. The variable values that are larger than the mean result in a positive deviation. We don't want to deal with positives and negatives together, so we next square each of our deviations. After we've squared our deviations, we need to multiply all of those square deviations by their corresponding probabilities. So we'll go down the line and multiply the probability for each row to that square deviation that we just found for each row. Last, we need to add up all of the products. We get 1.5 is the sum of all of the square deviations multiplied to the corresponding probabilities. And then lastly, we take that product and we put it inside of the square root to finish this off. So sigma, our standard deviation, is the square root of 105, which is approximately 1.0247. And so together, these numbers, the mean and the standard deviation, summarize our probability distribution function. We have a mean of 2.1, standard deviation of 1.0247.